Hello, everybody. We'd like to welcome you to Expert Tips when upgrading the ELK stack. I'd love to say good morning or good afternoon, but as a relevancy joke, depends what side of the world you're tuned in from. So thank you for being here today. Our intent with this webinar is to just share our firsthand experiences as Elastic consultants as we've worked with customers performing upgrades from legacy versions of Elasticsearch to the most current release. Our hope is that you find some insightful tips to make your upgrade process that much smoother as you consider moving to our latest and greatest features. We're going to go ahead and get started with some introductions so you know who everybody is. I'm Daniel Marr. I've been with Elastic for about 5 months now, and I'm a consulting engineer. My background is in cybersecurity, although over the years I've honed my experiences in systems and networking as I've moved along my career. I enjoy hiking, spending time with my wife, and if you didn't catch the invite that went out, I'm an avid fan of Star Wars, so may the Force be with you. Next up is Saud.
Hello, my name is Saud. I am a consulting architect with Elastic. I'm happy to join this webinar and will be happy to share Elastic Stack knowledge.
Thanks, Saud. So some quick housekeeping and logistics. This recording will be available following the webinar, so you can watch it on demand if people are not tuned in today. So if you have any colleagues or friends that you'd like to share this with, please send them the link after the webinar is over with. Also, if you'd like to take advantage of the IRC channel, this information is available here. Please join and ask any questions that you may have. At the end of our presentation, we'll highlight some select questions and just have some time for some general Q&A at the end. If you're using the YouTube video player, it's recommended that you please select the highest resolution so you have the best experience possible during this webinar. So this is our agenda for today's webinar. Although some of you may be intently familiar with the Elastic Stack, for those that may not be, we're going to quickly cover our products and just go over the stack and just give everyone a general idea, and we all start on the same page. Then we'll switch over to Saud, and he'll talk about the different options and strategies you can take for upgrading your Elasticsearch products. We'll talk about some breaking changes, although we won't cover them all. There's many that would need to be addressed, but we're going to try to highlight some of the key ones that we've noticed customers having issues with the most. We'll then transition into infrastructure considerations, talk about the cluster health, making sure that you're actually ready for an upgrade and that the cluster can sustain a successful roll over to the next version. We'll consider indexing, making sure we haven't missed anything and we're aware of where all the data is coming from. We're going to talk a little bit about disaster recovery, making sure that if you do need to roll back, that your data is available for that option. And then we're going to talk about bootstrap checks, just different things that Elasticsearch needs to have set correctly or it won't start. Finally, we'll end things talking about optimizations, mainly having to do with the sizing of your indexes and modeling your data so that you can have the best experiences with the products moving forward. So first up, we're going to talk about the Elastic Stack. So coming in first is the original product that was out years ago, Elasticsearch. Elasticsearch allows you to store, search, and analyze your data. It's the heart of the Elastic Stack. It's distributed in nature, and it allows you to spread the workload to multiple nodes, and you can also assign dedicated node types to take advantage of advanced features such as machine learning. It does provide RESTful APIs, so you can take advantage of many features that have been integrated into the Elastic Stack. But how do we get data into the Elastic Stack? Well, that's how we have to handle things with ingest. And the first product up that handles that is Logstash. Logstash is a dedicated ingestion workhorse, and it can collect data from a variety of sources using different input plugins. So whether you have a TCP plugin and you're bringing in connections that way, or maybe you're logging syslog and you set up a UDP plugin, or taking advantage of beats, Logstash is a powerful way to not only receive the data in an ingestion pipeline, but to do advanced data enrichment before sending it to Elasticsearch. But what about your endpoints? How do you move data into Logstash or to Elasticsearch directly? And that's where Beats comes to play. It comes in a variety of flavors, but for those who just got excited, I'm not talking about ice cream. Beats are lightweight data shippers that are written in Golang, and you deploy these on different endpoints on your network. You have WinLogBeat to take advantage of shipping your Windows logs, AuditBeat if you want to ship stuff from Linux. You can use FileBeat to tail files of different types. Maybe you have that DHCP server and you'd like to tail those logs, or another proprietary log format that you need to send to Elasticsearch. FileBeat can take care of that for you. Perhaps you're interested in the network data off of your endpoints and you'd like to send that into Elasticsearch. You can leverage PacketBeat to look at the HTTP traffic to a server, or maybe the DNS queries. If you're considering the metrics on your systems, you can deploy MetricBeat, and that'll collect those metrics and you can send them to Elasticsearch. Finally, Heartbeat allows you to monitor the uptime and make sure that critical services are working as intended. We've moved the data into Elasticsearch, but how can we check it out? Well, Kibana provides us a wonderful way in our browser to visualize and manage our data. You can build visualizations, add those visualizations to custom dashboards, and manage your data as well with the DevOps tool and check on the health of your cluster. You can also take advantage of advanced monitoring features to see how everything is going. While the Elastic Stack has been deployed by many customers, in our experience, we've seen many different use cases, and we like to call these solutions. These are proven ways that we know the Elastic Stack handles data very well. Some customers use it for logging. Others just collect metrics on their environment. APM is a new feature that allows you to monitor the performance of your applications and look for any problems in your application code. Security analytics has become quite popular as the rising cyber threats have increased. More and more people are leveraging the Elastic Stack in the SOC environment to detect threats and adversaries on their networks. Maybe you need to conduct business analytics to give your business that cutting edge based on the data set that you have to analyze. The Elastic Stack's a powerful way to get the insights from your data that's useful. Finally, with the acquisition of SwiftType, the Elastic Stack offers application search, site search, and enterprise search. Deploying the Elastic Stack can be done in a couple different ways. Maybe you want to deploy it as software as a service and you're more of a cloud person. You can take advantage of our cloud offering. But perhaps you have a standalone environment and you have the infrastructure to do so. You can take advantage of Elastic Cloud Enterprise, which will allow you to stand up multiple clusters on the fly, make your upgrade process much easier, and you can deploy that on-prem or in the cloud. Finally, the last way to deploy the Elastic Stack is a standalone installation for those who maybe have a smaller cluster and only have the need to have a couple of nodes taking care of their use case. Now that we've done an overview of the Elastic Stack, Saud's going to go ahead and cover the different upgrade strategies you'll typically run into when performing upgrades on the Elastic Stack.
Okay. So okay, so the next step is to look at the upgrade strategies. Upgrade, strategy is one of the most important step when you are trying to do an upgrade. Before we can get into that, let's discuss the versions of Elastic. Elasticsearch releases its versions in x.y.z format, where X is the major version, Y is the minor version, and X is the bug fixes. Another important thing to notice regarding Elasticsearch versions is that Elasticsearch skips the major version 3 and 4, which means that the first version was 0, then we moved on to 1, and then we moved on to number 2, and then we skipped 3 and 4 and moved directly to version number 5. While dealing with the upgrade strategies, we can categorize them into two major categories. One is the in-place upgrades, and the second one is side-by-side upgrades. So while planning the upgrade, we have to see that either one of these strategies or a combination of these strategies can be taken to do an upgrade. In the next 4 slides, we are going to go through each of these strategies and see how they can help us achieving the upgrade. Next. The first one is called the full cluster restart. As the name suggests, you will have to do a full cluster restart to do an upgrade. Now, because this involves a downtime, we try our best to avoid this. If you are using any version which is less than 5.x, an earlier version than 5.x, then if you want to do an upgrade, you will have to do a full cluster restart. If you are currently on version 1.x, you will have to do a full cluster restart to move to 2.x. And if you're on 2.x, you will have to do a full cluster restart to move to 5.x if you want to do an in-place upgrade. Now, another important thing to remember is that before you even try to do the full cluster restart upgrade, make sure that all of your Elasticsearch indices, their Elasticsearch version, should be equal to your Elasticsearch cluster version. Now, you might think that how could this happen, that your Elasticsearch version for the indices can be different from your Elasticsearch cluster version. Assume you started using Elastic in 1.x, and then you upgraded to 2.x using a full cluster restart. And your current version is 2.x, and now you want to upgrade to 5.x. Remember, you started in 1.x, so you have certain indices which were indexed using 1.x. Now, your current version is 2.x, so you have indices which were created on 1.x. Now, before you can upgrade to 5.x, doing a full cluster restart, you will have to make sure that you create a new index in 2.x, reindex that data into that new index, delete the old indices, and then you are ready to do a full cluster restart. Next. Okay, so the next strategy for the in-place upgrade is a rolling upgrade. Rolling upgrades require zero downtime. Reason is, as the name suggests, rolling upgrade, we do upgrade one node at a time. So as part of your cluster, you will select one node of Elasticsearch. You will stop Elasticsearch there. You'll do the upgrade and put it back as part of the cluster. Because Elasticsearch is highly available, you can do this without any zero downtime. The rolling upgrades historically have been for the minor version upgrades, which means if you're using version number 2, you can move from 2.x to 2.y or 5.x to 5.y using the minor version upgrades, rolling upgrades. The good news is that from the version number 6, if you are currently on version number 5, what you can do is you can do a rolling upgrade to the latest version of 5, which is 5.6. And then you can do a rolling upgrade to 6.x. You don't have to do a full cluster restart for this major upgrade. So this is a good thing to move to 5.x so that you can in future have these rolling upgrades. Elasticsearch would like to keep the rolling upgrades for the major version upgrades for the foreseeable future. The same thing is true for this rolling upgrade as well. Make sure that all of your indices have the same Elasticsearch version as your Elasticsearch cluster version. Next. The next kind of strategy is the side-by-side strategy, in which you don't upgrade your existing cluster, but you try to create a new cluster on a side with the newer version of Elastic, and then you try to reindex the data there, or you try to copy the data there. One of the approaches is called the snapshot restore, in which you take a snapshot on your existing cluster, and what you do with that is you try to restore that snapshot into the newer cluster. This side-by-side approach works the best because it gives you ample time to test your newer cluster, giving ample time to your QA team, to your application teams to change your code. But remember, if you're trying to do the snapshot and then restore into the new cluster, make sure that there will be some indexing downtime involved. There will not be any search downtime, but there will be some indexing downtime involved because you want to make sure that both of these clusters are in sync. Snapshots are incremental, which means that the first time you take a snapshot of your existing cluster, that will take significant amount of time depending on the amount of the data. And once you restore that into the new cluster, then you can go back to the existing cluster, take a new snapshot, will be just the delta of what has changed since then. And then you can restore that into the new cluster, which will take less time. The same thing is true here for a prerequisite, that you have to make sure that you don't have any indices which are part of that snapshot, which does not match the cluster major version. Otherwise, if you do have such snapshot and you try to restore that into the new cluster, your node will not start after restoring. Next. The next one is side-by-side upgrade with the remote reindex. This is my personal favorite, and this is the safest method. So what we do in this approach is that we create a new cluster with the newer version of Elastic, and then we try to reindex the data from your existing cluster remotely into the new cluster. And you can use the Elasticsearch reindex API for this purpose. This method, has zero interruption, zero downtime, and it can be achieved for any kind of upgrade, regardless of if your current version is 0.x, 1.x, or 2.x, or 5.x. You can move directly to 6.x using this approach because you're reindexing your data anyways. The side-by-side remote reindex works pretty good for the major version upgrades. For the minor ones, we prefer to use the rolling upgrades. Make sure that when you are using this strategy, have a strategy for the delta sync, which means that once you switch over to the new cluster, since you have lost taken, reindex your data, make sure that you are able to catch up with your existing cluster. This can be achieved using query along with the reindex API to take the delta, or make sure that you're writing to both clusters so that your data is in sync. This strategy also gives you an option that in case if things go wrong on the newer cluster, and you are keeping the data in sync on the old cluster and the new cluster, you can easily go back to the previous cluster, sort out the issues, and then switch back again to the new cluster. This strategy is liked by most of the DevOps because they have plenty of time to give to the developers and to the QA guys to test this cluster before they make a decision to switch over. Give it some time, maybe a week or 2 weeks, and when you're happy with the new cluster, you can go back and decommission the old cluster. Now, the question may be that if this strategy is that good, why not use this strategy all the time? The answer is that sometimes your cluster is so big, it's not feasible to create a cluster of the same size for side-by-side upgrade. If it is a possibility, this is my favorite to go. But if it's not a possibility, then you do have to do a full cluster upgrades for the older versions and the rolling restarts for the newer versions. Thank you.
Thank you, Saad. Now that we've taken the time to consider the different strategies for doing upgrades, it's important to go ahead and look at key things that you're going to want to pay attention to make sure that you have a successful upgrade. We're going to take some time to go ahead and talk about breaking changes. As I noted during the agenda overview, we cannot cover every breaking change. There's many depending on how far out you're upgrading your cluster from. But nobody wants to be sitting on the other side of an upgrade, staring at a log full of errors, or worse, a cluster that won't start. We're not going to cover every breaking change, but we're going to just highlight the most common ones that our customers tend to have trouble with, or ones that they tend to overlook. So the first thing that we're going to start with is one that's probably become the most popular, and it's the transition we made in 6.x to using a single mapping type. Historically, you could have multiple mapping types for your documents in an index. The type meta field could then be used to limit searches to one or more types in your index that was being searched. In the past, we had an analogy that compared an index to being a lot like a SQL database, and that a type was a lot like a table in that database. Unfortunately, that was a bad analogy because those fields that have the same name across multiple types that are in the same index are backed by the same Lucene field internally. Another issue that arises is sparsity when folks would create multiple types that had very few commonalities in fields. Therefore, because of these limitations, we are moving towards removing mapping types completely. In version 6.x, you can only have a single mapping type, and in future versions, it won't exist at all. This is currently deprecated as we move forward. So where are some places that you need to pay special attention to when considering single mapping types? First, assuming you're using Logstash, you're going to want to go and look at the output plugin that you're using for Elasticsearch and make sure that you pay special attention to whether or not you're calling out the document type parameter and predefining your doc type upstream. If your mapping for the index that Logstash is going to write to is set to a different doc type, you are going to have lots of errors. So you're going to need to next move to checking your templates. Hopefully you're leveraging the power of index templates in Elasticsearch. Here we can go ahead and predefine the single mapping type that we want to use, and then in Logstash we can make sure that those line up. If we're taking advantage of the rollover API, which we'll talk about later on in this presentation, that will ensure that we have a single mapping type and that we don't run into any errors by trying to create the default doc type, which is now doc. Now let's go ahead and talk about some key mapping changes that tend to surprise a lot of customers. The all meta field is now disabled by default. What the all meta field used to do is it contained a copy of the text from each field of your data. Many folks used query string and simple query string queries that would look at the underscore all field. All hope is not lost, though, with those query options, as the query string and simple query string will check the underscore all field to see if it is enabled or disabled. And if disabled by default, it will look at all fields. However, we want to call out the underscore all meta field because some customers tend to write custom queries in their application code or in other places, and they rely very heavily on this meta field. So we like to point it out so that they're aware and they don't run into problems after they do an upgrade. Consequently, because the all meta field has been disabled, the include in all option is now also disabled by default, and you cannot use it in 6-dot indices moving forward. Next, let's talk about the Java high-level REST client. In version 5.6, this client was released and will soon completely replace the transport client. It's important to point this out because some customers are relying heavily on the transport client. Also, if you're making use of other languages like our Python client or any other language, make sure to use the official clients, as those are the ones that are supported. This next one catches a lot of folks by surprise, and it has to do with the JVM heap dump path. In previous versions of Elasticsearch, installation packages, let's assume you're using RPM or dev, that would not configure this dump path for you. So by default, the JVM would default to using user share Elasticsearch, or essentially whatever working directory the JVM had. And this is a problem because the JVM would not have write permissions to that directory. So what does that mean for you moving forward? Now, from 6.0 and forward, the default heap dump path is set to varlib Elasticsearch. It's important, though, for you to make sure that you define where you want your JVM heap dump to go. You may not have enough room at varlib Elasticsearch, and so maybe you call out a different location. This is important to understand because in environments where the JVM may be tuned to have a heap of, let's say, 30 gigabytes, you might be looking at a JVM crash, putting out something greater than or equal to 30 gigs of space, and that might be a problem for you. JVM heap dumps are critical to doing good diagnostics when you're running into problems, and so you want to have this information available. When sharing it with support, you can also compress it to make it a little bit easier to deal with if those heap dumps tend to be a little large. Another thing that tends to catch folks by surprise are the changes to queries and scoring. You're going to want to make sure that you take a look at these changes. You don't want to be using queries that have deprecated settings, or even worse, parameters in your queries that have been completely removed, have a successful upgrade, and then have a bunch of frustrated users that can't perform their queries. Or maybe you expect scoring to happen a certain way, and fundamental changes in Lucene have happened that change the way scoring affects your documents. You're going to want to take a look at that to make sure everything's compatible when you move forward. Now let's talk a little bit about scripting support. In version 5.0, you could use Groovy, JavaScript, and Python as scripting languages to do things to your data in Elasticsearch. This was deprecated, though, starting in 5.0, and since has been completely removed in version 6.0 and beyond. You're actually going to have to use Painless now. Depending on who you are, you may or may not like Painless, but we do have good documentation available on our website, and I encourage you to check it out, as it is the only supported scripting language now for using with Elasticsearch. You also want to pay special attention if you are utilizing file scripts, as that feature has also been removed, and you need to use the script store instead. If you're using search templates, you will also use the Stored Scripts API to store those search templates moving forward in 6.x. Finally, this last item, as of version 6.0, if you're using production license and you're enabling security, you're going to have TLS for the inter-node communications of your cluster. This catches a lot of people off guard, but TLS is important because it provides confidentiality of the data in transit between your nodes, and integrity as nodes join the cluster and communicate with each other. This gives you an extra level of security to make sure that other folks aren't interacting with your cluster and doing malicious things. So maybe you're having trouble figuring out how to get those TLS certificates created. You can take advantage of the Elasticsearch CertUtil utility that ships with Elasticsearch by default. You can either generate the X509 certificates yourself, or you can generate certificate sign-in requests for your CA to sign upstream. One of the easiest ways to get all those certificates set up, including Logstash, Beats, Kibana, is to configure those in a YAML file and run the CertUtil utility in a silent mode, and it will you pass it the CA that's going to sign the certificates, and the output is a certificate bundle that you can use to distribute certificates and configure your environment accordingly. Next, we're going to go ahead and move on to infrastructure considerations. One of the things that we stress time and time again with our customers before starting any upgrade is to take some time and look at the cluster health. You don't want to perform an upgrade on an unhealthy cluster. It's just a recipe for disaster. So we're going to go ahead and discuss some important issues to consider that deal with your cluster health and the cluster configurations. One of the first things we like to look at is high CPU load. Some customers may run multiple applications on that node. That's also eating up more CPU. So high CPU usage is something to be concerned about, and we usually like to try to figure out what's going on with that node. But even more importantly, we like to hone in on heap usage. If you have nodes that are crossing that threshold of 75% heap utilization, we're starting to experience quite a bit of memory pressure on those nodes. And so in situations like these, we want to relieve this memory pressure before proceeding with an upgrade, and we have a couple of options to do so. As you've probably heard from an Elastic consultant before, or anybody who's used the product for some time, it's a distributed product by nature, and we encourage you to add nodes to reduce this memory pressure on existing nodes. However, if that's not possible and your heap is currently less than 30 gigabytes, you could consider scaling vertically so that you could add a little bit more heap, but remember that adding nodes is preferable. Finally, if neither is an option for you due to resource limitations, you may consider snapshotting off old data or deleting it completely to relieve pressure on the heap. The next thing we want to pay special attention to is JVM compatibility. Perhaps you're moving from a legacy implementation of Elasticsearch, and you may have Java versions installed that are no longer supported with the next version of Elasticsearch that you're moving to. You're going to want to pay special attention to this, and we encourage you to check out our support matrix online, which also shows you compatibilities between versions of Elastic products, although we do encourage you to keep your Elastic products on the same major minor bug fix releases. Next up is disk space. Running out of disk space without realizing, especially after an upgrade, is not something you want to be looking at. So we go ahead and take the time, if we see issues here, to make recommendations to either increase that disk space, allocate more nodes, and so on. Doing this just makes some things a lot easier and allows for a smoother upgrade as we continue to ingest more data into the Elastic stack. If you're having slow queries, we may recommend turning on your slow query log and just trying to find any performance issues, maybe even poor indexing that's going on with your cluster prior to starting the upgrade. You don't want to be looking at the side of post-upgrade and realize that you have performance issues that pre-existed the upgrade. You're troubleshooting things that should have been addressed sooner. Finally, we take a look at any other configuration issues, whether or not you've enabled minimum master node settings so that you can avoid a split brain. We want to make sure that your logging is configured correctly so that we're able to do adequate troubleshooting, disable swap, and so on. So you're going to want to consider those things. So what about indexing? One of the best things we can do as a consultant on site is to have a thorough understanding of your infrastructure, your use case, and how data is getting into Elasticsearch. So when you're planning for an upgrade, you don't want to be missing that data source that's being ingested into your stack that maybe that last guy who moved on to a new job 3 years ago set up for you. Or perhaps you have some stateless syslog data being ingested in and you're going to start doing a full cluster restart or rolling upgrade. You need to consider, will this data have somewhere to write to? Do my SLAs allow me to lose that data for a period of time? These are important things to consider. Next up are single points of failure. We had a customer at one point, they were using dedicated coordinating nodes, but they had also installed Logstash on top of those nodes, and the output of Elasticsearch was writing to localhost, and they wanted to perform a rolling upgrade. Well, you can probably see the problem already. In bringing down that Elasticsearch node, they would not have a true rolling upgrade because Logstash only knew to write to localhost, and therefore there would be some data loss there. So you want to look for single points of failure in your infrastructure, and you're going to want to implement load balancing, whether that's a dedicated load balancer or you just spread that load from Logstash across multiple data nodes in your cluster. And then finally, just taking a look at architecture best practices. You may have a use case that warrants using a hot warm indexing architecture or something like that. And this is just going to depend from customer to customer. As Saud mentioned earlier during the upgrade strategy, using snapshot restore functionality is one way to do an upgrade. But more importantly, no matter what, when you start an upgrade process, you're going to want to get a backup of your data. So the snapshot restore plugin is a great way to do this before you start the upgrade. To do so, though, you're going to have to configure a repository. So a shared file system is going to have to be shared across all eligible master and data nodes in your cluster. And we have different plugins that are supported, which include S3, HDFS for Hadoop, Azure, and GCS for Google Cloud. Or you can just use a simple NFS share in your environment. You're going to have to make sure that these repo settings are configured in path.repo across all master and data nodes. And like I said before, that shared file system has to be mounted on those nodes as well. You'll use a snapshot API to verify that your repository is configured correctly. And then you'll run a test snapshot, and you're going to want to test that snapshot and make sure it's not corrupt. Like I said, you don't want to be on the other end of what you think is a successful upgrade, or even worse, be in need of a snapshot and only find out later that it's corrupt. Finally, backing up historical configuration files is a good troubleshooting technique and allows you to see what things looked like prior to the upgrade. So in this next section, we're going to go ahead and take a look at bootstrap checks. But what we really are trying to call out here are any settings that can prevent your Elasticsearch nodes from starting up. This includes important system configuration settings like the number of threads, file handles, memory lock, and so on that Elasticsearch requires to start successfully. You're going to want to also look at your JVM option files and make sure things that need to be set correctly, like your heap size, and most importantly, like we talked about earlier, that JVM heap dump path are configured accordingly. Consider file permissions. We tend to have customers that don't usually follow the general recommendations or have custom users and things like that. And the ownership and permissions of the files aren't set up correctly, which causes errors and prevents Elasticsearch from reading critical files that it needs to start. You're going to want to make sure for your network settings that you bind your HTTP and transport to the appropriate network addresses or interfaces, and that if you're not wanting to use default ports for security reasons, that you set those in your configuration files and make sure you document that. Finally, a quick story about configuration management. It seems most consultants have experienced a well thought out configuration management process that would go in and overwrite critical files every hour to make sure that configuration management was in place. However, we've all experienced customers that you're doing an upgrade, you put in the important system configuration settings, and the customer forgot to mention that configuration management was overriding those files. So an hour later, when you're troubleshooting and wondering why now you're getting a brand new set of errors because Elasticsearch won't start failing bootstrap checks, then they go, oh yeah, we have these configuration management tool doing this. So if you have similar settings in your environment, keep those in mind and make sure you schedule that stuff ahead of time prior to starting your upgrade. Finally, we're going to end by talking a little bit about optimizations, and that has to do with index sizing and data modeling. So when we're talking about index sizing, we're really looking at the different shard sizing strategies that customers are using. Over-allocating shards can be useful, considering Elasticsearch is a distributed system, yet too many shards can be a bad thing. Maybe you have a horror story of inheriting a cluster with 10,000 plus shards, maybe even worse, 20K. I know I've been there. You don't want to be in that situation. It's not healthy for the cluster because every shard comes with CPU and memory overhead, and it's taxing. Your cluster will just flatline. So what's the right answer to how many shards per index? Well, in a typical Elastic fashion, our answer is it depends. We typically recommend that optimal shard sizes are somewhere around 50 GB. The reason for this, it has a lot to do with shard recovery in your cluster. Larger shards take longer to rebalance. But also make sure you key in on having replica shards. Having a single replica allows you to have high availability for your index in the event that something goes wrong with the primary shard or you lose a node. But don't go crazy here. You don't need a ton of replicas. One replica is usually fine. Finally, one of the slickest ways to manage the size of your indices once you've determined it is to leverage the power of Elasticsearch Curator. Elasticsearch Curator, if you're not familiar, is a tool written in Python by one of our Elasticsearch consultants, and it helps you manage your indices in many different ways. While it has the ability to do snapshots, open and close indices, and many other features, the one that we want to call out here has to do with the rollover API. You can create curator jobs to run on a scheduled basis, and you can utilize something via cron or task schedule to do this, and it can go out and check your indices, and upon certain conditions being met, such as the age of the index, or maybe the size, more importantly, it will go ahead and roll over your index. That means it will create a new index, switch over the right alias so data is being written to the new one, and it keeps the size of your indices under control. Finally, let's talk a little bit about data modeling. It's always great in the new version to go ahead and ingest a few sample documents. By default, if you haven't called out any mappings, Elasticsearch is going to map string fields to text and keyword, and it'll do its best to map integers and things appropriately, including dates as well. However, you're going to want to go ahead and take a good look at these field mappings and determine how you need to set things accordingly. Perhaps you want to add custom analyzers because you have data that needs to be read in multiple languages, or you're ingesting certain content in multiple languages, then you need to consider custom analyzers. Perhaps your use case is a ticket system and you need to be able to look up ticket numbers by just using the last 4 digits. So maybe you need a custom reverse n-gram analyzer. Elasticsearch allows you to do things like this. So don't forget to consider the way you analyze your text. Also, if you're using Kibana, it's important to note that adjusting field names and mapping types may have an impact on your visualizations. The important thing, no matter what, when doing data modeling is to test, and then finally test some more. It's going to make your upgrade process a lot smoother when you make sure you model your data right the first time as you go to use the new features with Elastic products. We'd like to thank you for this time, and we're going to go ahead and move to some Q&A.
Okay, so I can take the first one. Somebody mentioned that they are trying to upgrade Elasticsearch, and the Kibana node complains about one of the nodes not being upgraded or something. I assume that maybe you are trying to upgrade Kibana before your Elasticsearch cluster has been upgraded. So make sure that you do that in order. So your Elasticsearch cluster fully should have been upgraded before you upgrade Kibana. Another one was a typo on my end. And then there was a question about what about 5.x to 6.x? Is there any downtime? If you are on the latest version of 5.x, then you can do a rolling upgrade to 6.x without a downtime. And that will be true for future as well. So for example, when 7.x comes along, if you want to do a rolling upgrade to 7.x, then you will have to do a rolling upgrade within 6 to the latest version of 6, and then do a rolling upgrade to 7.x. Okay, there was another one that do we need TLS secure for the Elasticsearch version 6.4? The answer is that if you have installed XBack, which is by default part of Elastic now for 6.4, only if you go and enable security that you will have to do the TLS certificates. If you just enable monitoring and not enable security, you don't have to do the TLS layer for that. Okay, there was another question about the doc or underscore doc. The more important thing is that there need to be only one type per index. That could be a doc, that could be underscore doc. But if you want to, so what will happen is that, in 6.x, there is only one type. In the next version, we will be removing these types, and there will be only underscore doc, which can be used. So if you want to be more future oriented, then start using underscore doc from now onwards, so that you are at least good for 7.x, because in the version number 8, they will be gone. Okay. Is there an official document to recommend a 50 gigabyte maximum shard size? So the shard size depends on your kind of data, what kind of mappings you have, what kind of queries you are running. So it requires a performance testing to come up with the right size of the shard. um, 50 gigabytes, you might have heard it from one of the Elasticsearch, consultants or support guys. That number works good for event-based data or logging-based data, where we know that each document is kind of around 1 kilobyte size, and that's a rough number to throw to make sure that you can scale properly for Elasticsearch. Okay.
I'll do one here, Saad. So the question was, should I allocate more than 30 gigabytes of memory for ES? So because there's a ceiling for setting your heap, you don't want to go above 30 gigabytes. I'd encourage you to take a look at, there's an article, a blog that was written called a Heap of Trouble, I believe, on our blog's website. And it gives you a really good indicator of why that is. But what that leaves you with is that if you have a data node, 64 gigs for a standalone installation tends to be the max that you would want to go on the memory, because then you're allocating the JVM heap at 30 gigs, and the file cache can happily be used by the OS, and Lucene will take advantage of that extra memory as well. Let's see. There was a question, if given the choice, should I upgrade from 6.1 to 6.4 directly, or rather to 6.1, 6.2, 6.3, and then 6.4? You can definitely go ahead and do a rolling upgrade, because you're in the same major version, and the docs break that down really well for you. But definitely consider all those other things that we called out, just to make sure you don't run into single points of failure and things like that.
Yes, there was another question which was part of Kibana, that if you have existing Kibana patterns, can you create a visualization using both of those patterns? What you can do is, because you're allowed to create as many patterns as you like in Kibana, you can create a new pattern and make sure that it can point to both of those patterns, or the indices which those two patterns point to. Make sure that it covers both of those, and you should be good. In certain cases, when you're trying to create an index pattern, your index names, you haven't defined them in such a way that you are able to create a wildcard match for those. Then go ahead and create an alias, which are pointing to those indices, and then you can create an index pattern using that alias. Another question was, lost it here. Yeah, there was a question around Curator being available as part of Elasticsearch SaaS. Not the Curator, but Elasticsearch is working on something to have the index management as part of Elasticsearch, which would mean that a lot of stuff which the Curator can do for you, it will be part of Elastic for managing all of that within Elastic. That's as part of the roadmap.
Okay, it looks like we probably have time to answer one more question, Saad. There was one here. The question was, what if I want to go from 5.x to 6.x? Is there downtime? This may have been answered in the IRC, but I do want to call out something important. So you can definitely do a rolling upgrade from 5.6 to 6.x, and it can be zero downtime. However, remember what we said about TLS. So if you're moving and you're going to start using Elastic Security, formerly XPack Security, TLS is going to be required. So if you don't already have TLS configured in your 5.x cluster, you're going to have to do a full cluster restart, because nodes that are trying to use TLS don't like to talk to nodes that aren't using TLS. So that's something important to consider. Well, at this time, we'd like to thank everybody for signing in. We hope that you found this webinar helpful. Please check out our consulting page. Don't be afraid to look at our documentation, and we encourage all of you to continue to read our blogs and find more insightful tips on managing your Elastic products. Thank you.